Welcome to my session at the International PHP Conference about self-hosting continuous integration for your company or hobby project or whatever with GitLab. The motivation for this talk comes from some years back when I first attended this conference. I don't remember the year, and I really couldn't get into how to work with the PHP topics I learned at that conference. Nobody told us how to set up an environment that works, that actually performs tests and checks whether software works, or how to deploy stuff to some obscure target where it should run. So now I want to go into that topic a bit. It will be rather low level, like how to install stuff and what to combine to get a positive result. But still, I would like to check who uses continuous integration in any form during development. Okay, that's half. I would have expected more, but still that's good to have an audience for this part. Next question would be, who uses GitLab already? Oh, that's fine. Yeah, then. Another motivation is my company specializes in using open source software as much as possible and staying away from American cloud service providers for German data security regulations and pure belief or whatever. So that is the matter for the self-hosted part in this presentation. What I would like to cover today is what you have to do before you actually get started with the project, installing GitLab for starts, how to get tests running and how to perform them in GitLab continuous integrations, how to get your application to a target location, and some aspects of how to perform database migrations in large applications. And we have not finished refining our process, so there will be a small chapter on how to get that better in the next years, and I would also like to welcome your input on that, what you have already done or what you would like to see. So when you get started with a fresh company or with a fresh concept, you need to structure it a bit beforehand. So it mainly depends on what kind of architecture you're building. You might want to structure your source code into some directories, or how to group project, what libraries to move aside into a separate project. This is very specific and cannot be generalized. I assume you want to use version control, so probably Git. Is anybody using SVN, Mercurial, ZVS? Okay, but still, I guess the majority is using Git. You should think about where to put some documentation, user guides, stuff you write down for other developers that will later join your team, such things. How deep do you want to go into testing? Is Sebastian Bergmann here? I hope not. Okay, so let's assume you will want to have a basic level of testing. And you might want to define some responsibilities. Perhaps there's a database team or middleware team or whatever, but still that is something to think beforehand if you are structured. If not, if you're agile, that perhaps you're not doing anything of that beforehand, but still it works. Regarding Git workflows, we discovered there are quite some things to think of beforehand. I have linked or put some URLs there to think about it. It mainly is clear that you have a master branch in Git somehow, but how to work with other branches can be a religious thing. Some companies might prefer this or that. Who uses, does anybody know Git Flow? Or GitLab Flow or GitHub Flow? No? Okay. So it mainly is how many branches do you want to have in your project and who is responsible for merging which branches in which directions. I can really recommend to read all three parts or a comparison you might find via Google. Who has a custom flow in his organization? 3, 4, 5. Okay. That's also interesting. Probably you might have to write that down then as well. So I put that here. It's one of the things that most of our new developers might start asking about, like what is that branch and why is it there, and where can I push now, and why can't I push there, and so on. So please write it down in some kind of developer guide. And if you want to work with the branches, you usually have some kind of associated environments. Like there might be a production branch that corresponds with a production environment, perhaps. Usually you need to set up those target environments somehow, have a hosting environment or a cloud provider or container farm or whatever. So this is not the scope of this talk, but you need to do that beforehand. Now, GitLab, which we choose for version control and all kinds of other things, is just one provider for Git repositories. It's quite like GitHub, but not quite like GitHub as well, because you can host it on your own server for no cost at all, aside from infrastructure. GitHub offers you the possibility to create repositories for your organization online. You have paid plans, you have free stuff for open source software, and GitLab is basically the same thing on your own server with some additional features. To set it up, you can either choose the easy way. There's also a hosted version with paid plans and all the stuff, but that is not, the talk is about self-hosting things, so I guess we won't choose that. And then it's really easy. They have a bundled setup that includes everything. You'd only have to have a virtual machine where to run it, be it at your own local cluster or in some cloud. You can create the you can integrate the repository they provide and just install the package, and then it's running. My system administration guys always hate me for that because it bundles its own database, its own Redis cache, its own everything, and they rather like to have the packages the operating system provides. But yeah, I hope you have the freedom in your company to just install it anyway. If you first install it, you might want to configure some nice things like LDAP integration into your local directory service, so you have all your developers in there beforehand. I would really recommend that. You might want to put your logo in there to distinguish it from other customers, Gits or whatever. And then you have it there. Beware, GitLab has a very active maintenance or development cycle. They really release a whole new release every 22nd of a month. So you at least have 12 major upgrade events in a year planned. But they make it hassle-free. You just do a yum update or apt-get upgrade, or how do you call it in that distribution? There's one central configuration file, this GitLab RB thing here. If you change anything in there, it will apply those configuration changes to all the distributed services, the GitLab bundles. And the reconfigure and restart will make them active in your GitLab instance. So, okay, that was very technical now. This is GitLab. It works in your browser, so it's very modern. You have a list of projects that you might be associated with, some toolbar icons like how much work do you have to do. If it's counting higher and higher, you might start to look at your backlog. And basically everybody you have in your GitLab instance can just start a project. Might be something you have in your free time, your employer leaves you, or you have some work project. You might create a group for associated projects, for a customer, for some kind of new business idea you start. And groups can contain many projects. A project is a repository and much more. like one group, one project contains one repository for software, but also an issue tracker only especially for this project, a wiki you could use, a place where you can store arbitrary code snippets. You can have merge requests and discussions within that project, and it always has a custom CI and continuous deployment pipeline for each project integrated. So this is what a new project looks like. You have a sidebar with all kinds of menu items, and this is where you would find the code. But there is no code because I just created a blank empty project. Let's fast forward a bit. I filled that project a bit with code because I want to spare you the development. My team and I recreated a really cool application. It outputs hello world. You can't find the repository on that URI, but I have not pushed all the things which are to come yet in this presentation about continuous deployment and so on. But still it works. It has a hello world example and it has some tests in there. I will fill in that after the talk, so you might go there for reference purposes later on. Let's start with testing that application. Who of you uses, I already asked who tested a bit, but who uses Codeception? Okay. All the rest uses plain old PHP unit? Okay. So to introduce you to Codeception, that's just a wrapper framework around PHP unit, which I will just use for a small test here. We install it with Composer and generate an acceptance test. So that's something that actually tries out your application and see whether it works. It could be testing a login procedure or checking whether requesting a new password actually sends you an email, which you can't really do with the unit test. But it also can integrate plain unit tests where you have assert equals and all the other stuff. This is our small acceptance test. So it checks it starts, the application checks where it is and whether it can see the text string hello world somewhere on this page. If you start up the repository and run the command line CLI server of PHP, you will see the hello world. And if I run that in my PhpStorm, it will pass. So great, we have a test, and it really has good coverage. Like there's nothing else in this application. That's a good starting point. What we want to do with continuous integration now is that we want to check our application does not break at a later point. Somebody might want to add something to the homepage and accidentally throw out our really important headline, hello world, which would be bad for our customers. So we try to establish an automated function that always performs tests when users do changes. And this is what you usually call continuous integration. It is, in this case, integrated into GitLab, but there are also other software components like Jenkins or Travis, or what else is there? What have I missed? Big ones. Is that okay? So GitLab makes sure those tests we have set up are performed every time somebody pushes something to our repository. It does that by distributing the work that actually has to be done to some kind of runners which perform the tests. You can define which kinds of tests are run per project. So it's a bit different from like Jenkins, where you have a separate software. If you want tests for a project that it's in your version control system, you have to set up Jenkins and tell it where the repository is and listen for hook events or whatever is used there and perform something then. GitLab integrates this directly into the project. So as a project owner, I can just set up my CI independently from everything else in the company. This works with a configuration file that I can just include in my repository. It's called .gitlab-ci.yml. YAML, YML, whatever, which also explains this weird syntax where indentions and dashes are really important, and if you mix them, strange things can happen. Not my idea. This is a basic example for setup of CI in our Hello World example. And I want to go into the different parts a bit. This is to specify a Docker image this was run with. Who does use Docker? Well, that's much more than 2 years ago. The advantage of using Docker here is that we have a self-contained environment that our tests can perform in and nobody gets hurt. Except Docker has some security issues, but that seldomly happens. So GitLab uses Docker. It tells all distributed runners to use a specific Docker image for all kinds of different purposes. And the tests we later set up in this file are performed within the Docker container that is running specifically for this event. But where does the Docker container come from? Which I did not show here is you have to install some components to run containers. As we are trying to establish a self-hosted environment, it makes sense to also self-host those CI containers. In our company, we just made it a requirement that everybody who has a computer in the company, which is basically everybody, should install a Docker engine and the CI runner of GitLab, which is 2 lines, like yum install Docker and yum install GitLab CI runner. And you have to just set up a communication channel between those two. So the clients, as soon as they're running, contact GitLab and ask for new jobs. Here I am, give me something. If there's nothing, nothing happens. But as soon as there is a build task, one of the clients in our pool start to perform some work. This is really low cost because we have a lot of unused CPU lying around in the company usually. And you don't need any kind of cloud infrastructure for that. It just works in the local network. It even works if people are working from remote places like VPN, because the communication is based on the client side. So the client has a Docker environment, and it has a connection to GitLab, so it can freely use any kind of Docker images. Who has already built custom Docker images? Okay, that's less than using Docker. So Docker principally defines Docker files, which are kind of descriptions what is in a container. There are a lot of things on hub.docker.com, which is a repository for templates that anybody else can create. There is a Docker template for like a Debian installation, or there might even be one for GitLab if you host it in a Docker container. We try to set up our own Docker container here. That's why there's a template line up here, which one to use. So that's our prefix. And we created a PHP 7.1 template, which is basically a blank Linux with some install commands for a PHP binary. This Docker image, we then upload it to our Docker Hub account, and GitLab will download that anytime it is requested. It can also be cached, so it's not really that much of a burden. This makes sure we have a built environment that we can define beforehand. So we know in this container there's a PHP 7.1 of a defined version which we installed. There might also be some libraries like SOAP or PSQL or whatever you might want to use in that. And if we write it here, GitLab will make sure this is used. If you write nothing in there, I think a plain Linux image is used. So no PHP there. Now there's a next part of the file that is called a job description. This file can contain any kind and any number of job descriptions, and multiple jobs form a pipeline in continuous integration. So this pipeline is quite small. It only has one job, which I call acceptance tests. The acceptance test performs 3 steps, basically. It does something beforehand, then it does some main stuff, and in the end it collects some files that are lying around after performing the job. In this case, for our acceptance test, we need somebody to run our composer because we don't have any kind of Codeception available or other dependencies that might be used to print out hello world, like a template engine or whatever. The actual script part is that what you would also run in your local command line if you want to execute the tests in your IDE. It probably is a button, but you still could use a command line. So it starts the web server in the background and then runs the Codeception. Oh, that was the wrong button. Codeception tests, which is equivalent to the green output we had beforehand, if everything goes well. And artifacts is something that I want to collect after the build runs. Normally, you have a test, and tests have output, like they produce a log file that everything is okay, or more important, if nothing works out quite right, they have a log file what went wrong. And in this case, I can say, collect this path here, upload it to a central GitLab storage path, and keep it there for 15 minutes, so some developer might get some insight from it. This is what it looks like if it is performed. If I push this repository with a file, a pipeline is created by me, and it's running as soon as some runner is free. In this case, it really happened with no delay, but if you have a high volume company and all your runners are busy, it might take some time until somebody picks up the job. Inside this pipeline, we have a number of jobs, in this case only one, and this is also pending. It's waiting to complete. If you look into that, you get a live output of the things that are happening in that Docker container. It's streamed via an HTTP API with some minimal delay, and you can watch what happens. Like, for example, it's running on the computer of my colleague Marcel. It's running with our image. Somebody has pulled the image from the registry, checked out our project from Git, somewhere here, and now it's running all the steps I defined in the configuration file. Until in the end, it looks good and has a check mark. If it doesn't, you'll get an email. There's also a browser plugin and all other kinds of means to inform the developer that something went wrong. Okay. Any questions to that point? Okay. Now, this is a really trivial test. Nobody wants to test Hello World anymore. So here are some suggestions what you could do in your continuous integration workflow. It depends on what you're working at, but you might want to consider having either unit tests or functional tests or even acceptance tests, or all three of them and all the other stuff that academic research provides us with. You might want to, if you're having a web application, you might want to perform cross-browser tests with different real browsers, for example. You might want to get some metrics from your test, like how much coverage do we have, or other static analysis stuff you can do. Yesterday we had a great talk from somebody about code smells and how to fix them, but I think you could also, of course, analyze code smells very deeply in here. I also recommend to have some really trivial things like, even though there are some really good debuggers for PHP, people tend to use var dump a lot. So if somebody commits a var dump, you might want to check whether there is one and then break the chain and not have that commit admitted to any kind of production release. Some people do really like code style, other people don't care. But if you're one of the guys who needs the bracket in the other line, please, then you might also integrate a check here on PSR2 conformity or Zend or Symfony standard or whatever you are using. And if you establish this, I won't go into how long the file looks now. It looks about like this. You suddenly have, in this case, 4 jobs running in one pipeline. In this case, you can see they have a different status. 2 of them are still waiting for some runners to be free. My colleagues obviously are busy using all our other containers. 2 are already running, and if we wait some more time, all of them have finished. And we can also get some coverage information now, or get the information that the pipeline has passed at all, to have a cool badge at our repository. Or whatever. You can also put the information into a Slack or Mattermost chat or whatever, so that you can be a bit of proud what your team performed. Okay. There is a GitLab CI example for this kind of setup in the repository, so you can have a look at that later. Now, continuous integration is also about other parts, not only performing tests, but you might want to have real integration tasks. Like you have your repository, which contains code, you have a lot of dependencies, you have your own libraries that you need to somehow link into the whole application before you can actually click and use a browser to perform some tests. So in all regularity, I try to introduce some build steps before we actually do the test steps, which is kind of weird because PHP does not really have a build process. Of course, there is a compiler, but it's not something we try to influence a lot. It just happens. So it's more of a virtual build. We have the source code. Oh, sorry. We have the source code, and you might want to put something in this whole thing before you package a release that you want to ship to the customer in form of a bundled zip, or that you want to push to your packagist or to wherever you want to deploy your releases to. So what do you want to do? For example, if you have some private repositories in your build chain, which might be the case if you're not developing open source tools, how can you integrate that? Basically, you have the possibility in Composer to list other Composer repositories, not only packages, but any kind of private packages, CETES, or even plain Git backends. Has anybody used the repository clause in Composer JSON? Yeah, okay, so that's some people already use it. But if you do that, you must make sure that the place where the composer is executed and tries to load those dependencies actually has access to those private repository that you linked in there. So your CI build environment, which is distributed to all kind of Docker containers floating around somewhere in your company, tries to access a private repository, which it might not be able to do. GitLab has a concept called private variables that you can configure via the web GUI, and they can be used during the build process without anybody getting a clue about the actual values in there. In that case, that means you are creating an SSH key, private and public, and you have the public key to tell the GitLab repository or any other kind of place it's okay to give that information away to somebody, and you hide the private key inside GitLab configuration. Now, in your GitLab CI file, you need to post that key file into a virtual SSH config file, or how do you call the key file? SSH ID, RSA dot whatever. So this is done with the SSH add command. And some other stuff like don't care whether the IP is trusted yet or not. It really looks ugly, I know, because it's broken and all stuff, but this is actually the recommended way by GitLab to put secure SSH communication in there. Might be refined sometime in the future. So this enables you to access all the private repository in your build process. Okay, any questions on that? No? Okay. Then we want to deliver that final product somewhere. We have a build stage that makes some kind of bundle out of our software. We have a test stage that goes over that and validates everything is okay. And then we want to publish it. Now it really depends on what you're working on. Sometimes you only have software that you provide as a zip release somewhere and upload it to storage, but you might also have real life environments if you're providing a cloud service, a website or whatever that you can actively deploy into and make the software run immediately. In that case, we would call it deployment to a server, which I try to figure as a workflow like this. If you're doing that, you probably want to enable some kind of maintenance mode in the target system so that people do not see any kind of strange things during development. You have to copy the new files over to the target environment. I'm really in the way, right? Sorry. Perhaps you have to apply some migrations because you have to transform the target environment in some kind, either the database or other. You have to move some temporary files around, or you decided some CSS paths are different in the future. You might want to clear some caches, and in the end, you just re-enable the application and everything works. This can be a manual process. Who does automated deployment somewhere? Wow, that's good. So I'm not talking to the wall here, that's good. And what I would also recommend is deploy documentation alongside. So because your application changed, you might have updated documentation. Do that in the same step and not forget about it. But the question still remains how to do this. This is some of the methods we have been using in the last 5 years or so. One traditional way is like go to the target server, have a Git clone, or you have a Git repository there already, you do a Git fetch and check out a new tag or release or branch or commit or whatever. That means your target system actually is a Git repository with all kind of history information that might be leaked, and which has a kind of authorization with your Git and association with your Git repository that you might not want to have out there in the public because your customer has access to the system or whatever. Still, it is a valid way of doing it. You might download a release from somewhere that you previously published on a kind of cloud storage. You might just want to copy files from where you are, from the deployment process, from the build process, directly to the target system. You can use something like deployer. Does anybody know deployer? Okay. Yeah, one. I would like to talk to you later because I haven't really gotten into that much. Or you can also publish the software as some kind of operating system package like RPM or DEP, or how do you call it in this other world, where you can bundle the software into. In our case, I would like to demonstrate how to deploy it with an rsync, which is something we end up quite often using. So I'm introducing a new job in my pipeline, which I call deployment to production. It has a new stage. Stages distinguish time during the build process, so it does not happen parallelly with a test, but only afterwards. I also have an environment flag and tell it only should work on the production branch of my Git. So I'm following some kind of GitLab flow here, or GitHub flow. I have an actual branch for my production system, and not every commit somebody makes should be deployed to production because it might not be ready yet. On the other hand, you might want to protect that branch against any kind of interference by people who are not authorized to do it, like protected branches in Git. So you define some project owners, 2 or 3 people in your organization who can actually decide what will go into production, and only they can trigger this CI pipeline as well, because only they can create push events on that branch. Okay, what is actually happening here? We try some kind of SSH connection before we do the file transfer, because we're following that 5 or 6 step workflow I explained just some slides ago. We're connecting as some kind of user to a system which has an IP address or hostname which is reachable, but which I also hide in some kind of variable to have it easier changeable and so on. And we execute our maintenance enable script. Let's assume our application has something like that. It might also have a framework like Symfony, which also has a built-in maintenance mode, so you might want to trigger that, whatever you feel free to use. Then we have an rsync, which updates everything and also deletes files which are stale from our local part here to our target system. But what we usually tend to do is we try to exclude quite lot of stuff, which we do not put in this line here because it's really a lot. Normally, when we're in that state during the build process, we have a copy of our repository with all the dependencies installed, with some things lying around like a gitignore file, a .git directory, and other stuff that is not recommended to be in the production environment. So we have an exclude file here, which hides all that stuff and prevents it from being transferred to the target system. Also, if you're using the delete option with rsync, it would delete any kind of file it encounters on the other side, which is not present in your local build. For example, a production config file that is lying around, and of course is not in your repository, because then it would be overwritten all the time. And you would have to put that into the exclude file as well to prevent it from being overwritten. After we copied everything, we tried to make a database dump, apply some migrations, which will be a later chapter here, and disable the maintenance mode. If anything goes wrong during that process, like copying doesn't work because we can't connect, is that a question?
How do you make a rollback with this method?
The question was how to perform a rollback. There will be rollbacks later on. Do you regard that as a question because of the migrations or of the files?
This way you cannot make a fast rollback like changing the sibling or...
Yeah, that's what... Okay, the question again was you can't roll back fast enough because you can't just change the symlink. It will take time to copy all the files. Yes, this is a basic thing. You could also like copy all the files into a separate directory, wait until everything's set up and tested, and then move the symlink of some kind of vhost to point to that directory. That is exactly what a framework like Deployer is trying to do. So I'm eager to talk to that guy behind there, which I only have tested in some version a year ago, and they had a quite rapid development. They actually also use rsync or other means on the lower level, but they have an abstraction up on top of that where you can just execute some kind of deploy commands, and they will do all the stuff, and in the end just change a pointer to somewhere. And they will also leave the old stuff lying around for some kind of defined time or version count or whatever. Yes, I think I would recommend that if it makes sense in your context. This is just a very simple example of just copying over. If something happens, your application will be in maintenance mode for some hours until you debug it. Yes, might not be the best way to do it. Okay, any other questions? No? Okay. Alongside deploying all that stuff, you should also deploy documentation. What we have found out is it is good to have the documentation somewhere alongside your code. So we try to have a docs directory with some kind of markdown documents, because markdown is what everybody uses nowadays, and you can really have a nice look at it in your repository. But you can also use any other kind of documentation. And then we try to use mkdocs, which is unfortunately Python software, but I've never found anything in PHP, which will build some nice HTML out of the markdown. You can define where it has to go. You can define multiple language suffixes and other stuff. And then we deploy that as well with an rsync or whatever, or within the same rsync even, because you have a whole build process. You can also put it together before you do the deployment. And I would recommend to do the same thing for like a Open API specification, or Swagger, like it was known before. So you have an up-to-date documentation all the time. So do not build your actual Swagger UI instance locally and then push it, but do it every time you do a deployment. Okay, one aspect that is important during deployment might be database migrations. Who is using an application that has a database? Okay. Yeah, okay. Never mind. That is quite a lot. So what we really had issues with is if you do actual deployments, partially automated or whatever, you have new source code and you have an old database, and it might not really fit together because you introduced a new column and somebody has to go there and execute something to insert the column. And also sometimes you need to change values because you restructured something. You might need to update some data sets to reflect a new column, or because you decided you're introducing a country flag or whatever, and you need to populate that. So that means you have to have migrations. Basically, migrations work like this. You start with an empty database in the beginning of your project, and every time you change your database, it's a migration. So it's migrating from a state A to a state B. Some projects also start not with an empty database, but with some predefined structure. So that would be migration 0, because nobody ever applies the migration, but you configure the database with a default template from some SQL file, and afterwards you have the migrations. Now, if you deploy to a production environment or whatever environment, you can also deploy the migration assets or instructions to that environment and execute them. But you should trust them. You should be able to know it will work out, and not that your database gets corrupted, or database migrations are never executed, and then you're running into problems. This is what several libraries try to do. For example, Doctrine migrations. Who uses Doctrine and migrations? Okay. What do the others use? Laravel? And they also have migration? Yeah, okay. I'm not better than the world, but I would like to say we really use our own stuff, because we inspected the rest and found them to have some flaws in the concept of deployments, like I introduced it before here. The problem is, if you're deploying something like here, that's our migration number 1, it gets executed in the target system. That is something that Doctrine migrations or whatever can also do. And alongside it, it has to put some information about going backwards there. Because if you have to roll back to the state previously known to the system, you also have to redo the database changes. Yeah? Now, for example, I don't know about Laravel, but Doctrine migrations has an issue there, because the information about migrating and rolling back is always combined in the same class. And if you roll back, that class is missing from the target system. So how do you roll back? Which is why we created something. Perhaps Laravel fixed it. Yeah, but so we try to fix that, and we do that like this. We have the migration file, which is executed, and as a trace, it leaves the rollback file in the system. The rollback file itself is not in our repository, but only instructions about creating the rollback file are in the repository. So we can do that sometimes, and then we have a database state, and now it happens that we have to roll back to the previous iteration, and this is lost. This is not in the target environment anymore, but the database still thinks it is. So we have the rollback trace file lying around, and our automated script now executes this. And thus the database can be reverted. Of course, you can't revert all database changes, because if you have created something, kept it for some time, you populated those values, and you roll back, you might lose production data. But I think you do not do that many rollbacks in your production environment at all, hopefully. So now it gets really small to read. That is an example migration file of our setup here. We are trying to add 2 new columns, because we detected users are using brute force to break user logins. We need 2 new columns, because we need to lock accounts and make them available again after some time period. So basically, those are the statements from up here wrapped into some kind of command. Because we use Doctrine, we try to apply the database migrations using Doctrine. That has the advantage that we don't have to configure a separate database connection during our migration steps. Doctrine already knows which database to use, so we don't run it using PSQL prompts or whatever, but rather use it using the Doctrine abstraction or CLI. And in the same step, after those are executed, rollback files are written into the system, which contain the reverse SQL commands. It really looks technical here, but you can also have a look at the repository later once I push the database part, which is not pushed yet. So this is principally like we have a numbered sequence of migration files starting from 0000 or whatever you want to until some higher count. And every time the migration is executed, it leaves a rollback file of the same name, so you can associate them. And our migration script, which I did not put here because it's quite lengthy, every time checks whether there is a migration file that has no rollback present, so that should be applied. Then if there is a migration file that has a rollback lying around, that is applied already, and you should not do anything. And if there's a rollback file lying around that does not have a migration anymore, apply the rollback, and we're back to where we want to be. Okay. I have no idea whether that is a recommended way, but it's something we came up with in the last years because we had problems with Doctrine migrations. Now, first thing is we want to test that because it really sounds weird what we do. We're running arbitrary SQL on some kind of production environment, and I won't let that happen before we test that. And the principle is really simple. During your build steps, you can have another test migration step, which has an empty Docker database from a Postgres container, which you can load down from Docker Hub, or it might be MySQL or NoSQL, and it's empty. Then you just run all the migrations in sequence and sequence and sequence, and afterwards you kill all the migration files. So you rerun your migration script, and it starts going back through all the rollback files, and then you make a structural dump of the database, and it should be empty. If it not is empty, you might have missed up to clean up something during a rollback file. And if something happens, like one of the SQL commands has an error, it will also break the chain. So you have validated your database migrations here. Okay. Then there's one point here about the future wish list for our projects. I've seen a lot about GitLab CI being able to have dynamic container environments for every kind of branch. So if you're having a feature branch, it can also create an automatic environment for you running in a container, which bundles all your application stuff. I have not found any kind of cool guides for doing this for PHP, so it's postponed, but I hope we can introduce that soon. I would also like to use the GitLab integrated Prometheus, which is a metric database or monitoring database to collect something like exception counts or failed logins or other metrics from our applications, feed that into the GitLab and, for example, visualize it using Grafana. As I learned something about code smells yesterday, I really would like to dive deeper into that and put it in our files. So perhaps you might find that in the repository soon as well, and do a common base repository for all our projects to get other developers start easier in our company. Okay, thank you for listening, and please come forward with your questions now.